Good evening and welcome to Slugs and Steins, lectures from UC Santa Cruz. My name is David Hansen, a co-founder of this talk series and one of your volunteer organizers tonight. With me is Mike Reapy, another co-founder and past president of the UCSC Alumni Association, Shana Kent, executive director of the Alumni Engagement at UCSC, and Diana Hogue, our university events coordinator. For those of you who are new, our Slugs and Steins series engages a UC Santa Cruz faculty member in discussions with you, the local community of the Monterey Bay and Silicon Valley, and our extended community online, with a goal of making us all Renaissance people. We want it to feel just like you're at UC Santa Cruz sitting in class, but with a drink in your hand and with no tests. Before we get started, and since we can't see you, we'd like to know where you're zooming in from and how many people are watching. A poll has popped up on your screen. Please give it a few seconds to give it an answer. Okay, now you should see the results of the poll, and no one's coming in from outer space, quite a few from Santa Cruz, otherwise the Bay Area and California, quite a few actually from other parts of the United States. So welcome. Tonight, we will be tipping our signs with Executive Director Darryl Wong of the Center for Agroecology. Agroecology at UCSC, fondly referred to by many slugs as the farm, has played an important and pioneering role in propelling organic farming forward, both in our state and beyond. Darryl has been with the center for 10 years, previously as research lands manager, and has worked across the center's production, education, and research programs, co-managing 10 acres of production fields, instructing beginning farmers, and undergraduate agroecology courses, and collaborating on faculty field research. Darryl's PhD research focuses on soil health, regenerative agriculture, and organic no-till systems in California. Darryl has farmed for over 15 years, and he spent 6 years owning and operating a diversified organic farm north of Santa Cruz. We will have a detailed Q&A at the end, but don't wait till the last minute. You can type your questions into the Q&A box at any time. If you see someone else's questions that you like, again, down in the Q&A box, you can upvote it and we'll ask it sooner. In a few days, you will find this lecture also on the UCSC Santa Cruz Arts and Lectures YouTube channel. We'll post the link in our social media channels and follow-up emails. Okay, does everyone have their Steins? Great, I've got your slug, Darryl Wong.
All right, thank you, David. I'm sharing my screen now. Hopefully everything looks good. And yeah, thanks so much, I think, to the committee for asking me to speak. I should say right off the bat, I'm not faculty at UC Santa Cruz, but yeah, I do my work on the staff side in the director role. So yeah, so today's talk, Quest for the Holy Grail Organic No-Till Farming. I'll talk a little bit about yeah, how that references later in the talk. And yeah, thank you all for coming out and being interested in this. Clearly a passion of mine, and I'm really happy to share some of what the research that we're looking at, some of what feels like very much the kind of cutting edge of organic and sustainable kind of research and ideas in ag right now. And also I might share a little bit just about some of what's happening at the center at the end of this talk. And then hopefully we'll have a lot of good time for Q&A. I will do my best to try to cater to everybody that's out in the audience without knowing exactly who it is. And so I'll go fairly deep on some of these topics. And if it doesn't feel like it's landing for you, hopefully there'll be other stuff that will be interesting as well. But I want to give, folks that are really interested a kind of a deep dive, but also stay at the same time fairly high level to try to contribute to some of this conversation around no-till and regenerative ag that I think is really present for so many people today. So I will start with, let's get this going. There we go. So a lot of people at this point, I think, have an understanding of how our agricultural system operates currently, right? Where over the past couple of decades, we've had an incredible increase in total agricultural output as it relates to farm inputs, right? In terms of our productivity and just how much food we're actually producing. That very much has come at kind of the expense of some natural ecosystems. And we really see an increasing portion of the landscape really dominated by this very intensive agriculture. And while that system has created a huge abundance of food, it has also led to what I think is very popularly understood as these really serious externalities that we hadn't quite planned for. So thinking specifically about biodiversity loss, nutrient pollution. So if folks don't know this graphic, this is shows kind of the nutrient flows for the Mississippi River basin and the eutrophication or kind of the nutrient pollution that can happen in the Gulf of Mexico as it relates to a lot of our agriculture, as well as just soil loss and soil degradation worldwide. So as the population, right, we know the population is increasing very rapidly, and we expect it to continue to do so. A lot of the narrative that I think that we hear currently is really around how are we going to feed all these people? And specifically, how are we going to improve these productive systems so that we can feed this increasing population? And this comes from all angles about just how much more productive we're going to need to be. Now, coming from UC Santa Cruz and some of our critical interdisciplinary lens on some of these topics, what we know is that the world actually already produces more than 1.5 times enough food to feed everyone on the planet. The issue is really about distribution, and it's really about kind of power and access around that food. That said, right, this kind of industrial and intensive form of agriculture, we still need to figure out how to do it more sustainably. And especially in the light of climate change. And this is something I noticed, in the slide, lots of people from Santa Cruz, lots of people from the Bay Area, and those of us in California are getting very, very used to these effects of climate change. So wildfires, droughts, flooding, and I guess increasingly now, even on the East Coast, folks are experiencing some of this. So what are some of the, currently, what are some of the moves in agriculture to address some of these sustainability issues? No-till farming is definitely one of, if not the largest push for, I think, addressing some of these issues with intensive and industrial agriculture. No-till, just to do a really basic definition, it's just defined as a system of planting where you just make a very narrow slot or trench in the soil and then put your seed or plant right into that with no other soil tillage, which again is just working of the soil to loosen it up or to do any weeding or cultivation. So the picture that you see here is a cover crop that's been laid flat, and you see those slightly open lines. That's where the plants are planted in that picture. Globally, no-till has been, under the kind of umbrella term of conservation agriculture, has been hugely kind of successful in terms of adoption, especially since the 1950s. So just to put it into a little bit of perspective, right, conservation agriculture accounts for almost 15% of global cropland, and you compare that to organic as a sustainable alternative, which only, I think, occupies about 5% of global cropland as of 2021. Now, what are some of the benefits of this no-till system? The really big benefit is really about soil organic matter and soil health. And I don't need to go through all of these bullet points here, but what is generally understood from the literature is that when you don't till the soil and you allow some of the natural processes to take place, you end up building your soil organic matter, which is a lot of kind of dead microbe bodies and dead plant material that has come into somewhat of a stable form. And it has, we like to call it the magic fairy dust of farming, because it does just a little bit of everything. It allows water to drain really well through the soil, but it also allows the soil to hold water really well. It allows for nutrients to cycle within the soil, but it also provides those nutrients to the plant. So it really is kind of the, like this magic dust that I say for farming. And again, in the organic movement, we've really promoted soil organic matter management for a long time. So really well documented impacts of soil organic matter and soil health from no-till systems. Increasingly, no-till systems are really looked to be very economically viable, especially over the long term. While there are significant kind of adoption costs, once you kind of recuperate your expenses in terms of the transition of the system, folks do see kind of net gain in terms of profit after about 10 years. The really big push, especially in the area of climate change and the focus on no-till, is really around CO2 emissions. So this is just a graphic that shows lots of the different ways that carbon moves through a farm cycle. But a lot of the research that's been done around no-till systems show that they can actually reduce farm-related CO2 emissions by up to 84%. A lot of that has to do with decreasing the number of tractor passes and the horsepower required in those tractor passes to do the deep and intensive tillage. But there's also quite a bit around CO2 release from soil respiration and things like that. There's also a really, a lot of folks are pushing no-till for the potential of soil carbon sequestration. And I say this different from farm-related emissions, because this is really about how much the farm system releases. Soil carbon stocks and soil carbon sequestration is about how much carbon we're able to pull down from the atmosphere and lock into the soil. And so when you look at the relative pools of carbon globally, you can see that the atmosphere has 800 petagrams. And again, I could tell you like to what decimal point the petagrams are, but just think about it's a lot of carbon. Overall plant biomass on the globe is about 550. Even in the oceans, there's about 1,000. But when you look at the soil, there's almost 2,300 petagrams of potential for soil carbon stock and storage. So when we think about how degraded those soils have become and the potential for increasing soil carbon sequestration, there's been a lot of real excitement from no-till systems. So if these systems are so wonderful and great, right? So what are the challenges right now for these no-till systems? The first one is really around this issue of soil carbon sequestration. And I think this is a point that I really like to make right up front, because I think a lot of times when people talk about regenerative agriculture and they think about no-till, right away we're thinking about carbon sequestration. And the truth is the jury is actually still out on whether you're able to sequester carbon in these conventional no-till systems. So what you see here is that a lot of the excitement on the right-hand side is a graphic of the 140 different comparative studies of tillage treatments. That red line actually indicates about a 6-inch soil profile. And for 140 of those studies that were compared in the early reviews of the potential for soil carbon sequestration, a lot of the studies were just looking at that 6-inch profile. Now, if you actually look at a corn root system, and this, again, the lines on the left match up with the lines at the right. So again, that first line is a 6-inch, is 6 inches. Corn systems will put their roots well down into 3.5 feet, 4 feet down into the ground. And so we know that, there's a lot more that's happening in the soil profile than just at those top 6 inches. So a lot of the math early on in the literature was a little bit off. And so when we look actually at deeper soil profiles down to into kind of the bulk soil and down into 70 centimeters, really getting down into that 2 and 3 foot range, what we see is that in these conventional no-till systems, even those that are 20 plus years old, we actually see a net loss of soil organic carbon when you look at the entire soil profile. You will see it sequester a little bit of carbon up in the top, again, 6 inches. But really what we tend to see is a just redistribution of carbon where you actually lose it at the deeper depths as you're not doing more incorporation of biomass and other organic materials into a deeper level of the soil profile. Again, I want to, swing back to this graphic and see that, right, there was a huge uptick in uptake of conservation agriculture, of no-till systems, really starting in the 50s. But it's not really this is not a new practice and it's not a new argument. In 1944, Time magazine published an article called Plow Row that post Dust Bowl. They said it was the hottest farming argument since the tractor first challenged the horse. And this was an idea of, right, we saw the results of really intensive tillage and losing all of the soil that blew all the way from the Midwest into the up to the Northeast. So given that that was such a hot argument in the 30s and 40s, why did it take so long to really have the adoption of no-till, again, both in the US and globally? And this is where we have to be really clear about the rise of no-till and the adaptability and the efficacy of it was really tied intimately to the development of new herbicides. And previous the first herbicides that were produced had long residence times and long plant back times. So you could use it to kill weeds, but you'd have to wait a significant amount of time before you could put plants in the ground. When we develop things like paraquat and diquat, what we know really currently is Roundup. These were broad spectrum, fast acting herbicides that had really low plant back time so that you could spray them and plant back within a matter of days or week. And that is really what allowed for the development of no-till research and no-till systems that, again, are mostly conventional. So again, the major issue here with the no-till systems we have right now is that the majority are really reliant on these herbicides that we increasingly are linking to cancer and linking to human health effects within kind of eaten food as well as exposure. This is just a slide. I don't need to go through the p-values here, but this is really just, again, in 2020, these are studies where they're looking at these conventional systems tend to use herbicides to what they call as burn down cover crops. So cover crops are something that organic practitioners have been using for decades. They're becoming really big in no-till and this idea of diversity and crop rotations and cover crops, but again, relying really heavily on herbicides to manage those cover crops in conventional systems. What that has led to increasingly is the prevalence of super weeds or herbicide resistant weeds. So this is an example of a field of wheat that, again, conventionally managed where they're spraying herbicides, but the more we spray, the more the weeds are kind of evolving quickly and evolving a resistance to these herbicides. So this is a significant ongoing issue for conventional systems, especially these no-till systems. When you look at the amount of cropland area that's under, again, no-till or conservation agriculture, as a percent of cropland by region, what you'll notice is that Europe really lags significantly far behind some of the other industrialized countries where that intensive agriculture is more prevalent. And that really is because of their higher regulation of pesticides and because of their reliance on no-till systems. And then the last point that I'll just highlight is that these no-till systems that have really been developed and adopted worldwide are really focused on what we refer to as commodity crops. So these are crops like corn, soy, cotton, and wheat, this slide on the left. These are incredibly different, almost worlds apart from the fresh vegetable systems that we operate in here in California. So this is a romaine lettuce harvest that you see on the right. But these are really vastly different systems with different labor requirements, different crop turnovers. And so many of these no-till systems have not been adapted for these kind of nutrient dense specialty crops that are really, again, we grow a lot in California. So the question, looking at kind of, again, a lot of the benefits of no-till around soil health, but all really addressing some of these issues around carbon sequestration, pesticide use, and crop and regional specificity, this idea of how do we improve no-till systems. And a real obvious one that comes up, and one that I think really speaks to this idea of the kind of quest for the holy grail is USDA organic, right? So organic is a really kind of proven system where we've seen it operate for a long time. We were able to use it without pesticides. across a lot of different crops. So how does it actually work, and what are the issues that come up when we think about it in regards to no-till? So if we look at carbon sequestration, this is, I think, one reason why I think this particular research, even though I'll paint the really significant challenges, but one of the reasons why it's really so important is the potential for carbon sequestration. So when we look at organic no-till and the potential of organic no-till to sequester carbon where conventional no-till cannot, I'm going to kind of dig a little bit deeply here. And if we start, I can answer more questions on it if it doesn't land exactly for folks. But basically, there's not really sufficient long-term studies. There's not that many systems that are over 20 years old that are operating organic no-till systems. But what we really want to focus on here from kind of a theoretical basis is when we look at soil organic matter accumulation, there's kind of an old or a classical model that we relied on, kind of a little bit over like 15-ish years ago, which really thought about soil organic matter, again, that magic fairy dust of farming, as being related to this is fancy language, the humic substances and recalcitrant molecules. But this is basically, if you think about a blade of grass that's fresh and green, and think about a blade of grass that's dried out and becomes straw. And the idea is that if you put these, something like straw into the soil, it's just going to be harder to break down. And because it's harder to break down, it will eventually, and the composition of that material will determine how long it takes to be in the soil to become soil organic matter and basically turn into that fairy dust. So this was really about the properties of what you added and how you added it. What we've learned as we move towards this emerging view of soil matter accumulation is that really what it is it's not these big pieces that we thought used to last a long time, but it's really about the interplay of the soil ecology and the microbes and the microbial processes that actually build soil organic matter in the long term. And the idea here is that soil microbes, healthy soils that have a lot of soil microbes, the microbes will grow, they'll eat the dead biomass that's in the soil. As they die, those really small, teeny tiny bodies are able to be physically protected by really small chunks of soil. And that is really the driver for long-term soil organic matter accumulation. So rather than it being about the inputs that you put in, what it really is about this cycle between, again, organic matter that gets eaten by microbes that then dies and gets linked up to this idea of absorption. It gets linked up to the soil particles and then released from the soil particles and eaten by microbes, right? But it's this actual cycling of carbon through microbial bodies that allows for this deeper leaching into the soil, as well as kind of the stability of this soil organic carbon. So when we think about sequestration, this is the kind of emerging view of how we look at it. So when you look at the literature, right, what are the management practices that support this dynamic stability of soil organic matter and soil organic carbon? It is a lot of these things that are already really prevalent in organic systems. So cover cropping is a really baseline, is a foundational practice for nutrient management in organic systems. High residue retention and high C input crops for a similar reason. Again, organic amendments, because, we apply things that have, think about, what we're applying to our soil as organic producers is manure or cover crop biomass that has a really interesting kind of nutrient composition. Whereas, what conventional growers might apply is nutrients in their kind of pure and kind of synthesized form. So they're giving exactly what we think the plant needs, but it's more of like an injection of sugar versus an apple. And this idea of kind of reduced tillage, again, really prevalent in organic circles when we think about how do we do responsive tillage to manage our soil organic matter levels. So when some of the long-term studies, and this has come out really recently, when we've looked at actual soil carbon sequestration at really deep depths down to 200 centimeters, What you'll see in this kind of bottom graphic is the kind of overall change in terms of carbon stocks. And what you'll notice is that the conventional tends to lose carbon. Even the conventional with cover crop can lose carbon. And it's only the organic system that has both cover crops and these diverse organic amendments that can actually see the potential for carbon sequestration. So, for me, this was some of the most exciting, this was kind of the exciting theoretical basis for why focusing on organic no-till is so important, because I think when we look towards the potential for agriculture to actually sequester carbon, what we're seeing is that it's this combination, this synergy and emergent properties that happen from, again, many of these practices that have been very prevalent in organics, but that we haven't really tried and been able to study. So what happens when we think about pesticides in organic no-till systems, and what are some of the issues that come up? So with organic no-till systems, what you see here on the left is a roller crimper. And you see it's going through a cover crop of Merced rye there. And the idea behind how these systems work in an organic system is that you allow a cover crop to get to a certain level of maturity. Then you will roll it down with that roller crimper. And what that does is it pinches the vascular tissue of those crops. And that will die in place. And essentially think about what you're doing is basically growing your own straw mulch in place, laying it down, and then planting that crop right into it. So what you see on the right there is soybeans kind of coming up through a rolled down rye mulch. So that's the idea in terms of how it works. The reality in terms of the practice is that it is very, very complicated to get this to work. In conventional systems, again, this works kind of really well and really easily because they use herbicides to burn down that cover crop. So it allows them to terminate the cover crop whenever they need to in their cropping cycle. Issues that organic practitioners of no-till have is that you really have to wait until that crop reaches a certain biological stage, i.e. it's starting to form its seed, but it hasn't formed viable seed yet. And then you have to crimp it at the right time. And there's all these kind of interplays that we have to manage around what happens when the cover crop regrows, when's the best time to plant a crop into a rolled cover crop that might still have some vitality into it. And so really addressing some of these really challenging issues around kind of cover crop sowing, what cover crop varieties we use, and what crops we can plant into them on the timing. One thing that comes up in this process is really about nitrogen asynchrony with organic systems. So again, as I mentioned, in conventional systems, they are allowed to apply synthetic versions of nutrients such as ammonium, right? And in this kind of nitrogen cycle, this ammonium is really close to its nitrate form, which is exactly what the plants will use. It's a couple quick microbial steps to turn into nitrates, which allows the plant to uptake that ammonium. As organic producers, we really rely on decomposers and microbes, which is really determined by environmental factors. So oftentimes when we apply our organic amendments, we need to have the right environmental factors to spur a flush of microbial growth that's going to decompose that fertility and allow it to become available to the plants. This is already an issue in tilled systems where sometimes we see mineralization of nutrients happen out of synchronization with our crops. But again, many systems have kind of worked towards that, but it becomes increasingly challenging in no-till systems. There's also this issue that comes up when we think about this trade-off between nutrient cycling and weed management. So when we think about the cover crops that we need to lay down to create a weed barrier in our organic systems, we want to think about putting down a cover crop that is relatively high in carbon. So we talk a lot about carbon to nitrogen ratios, and something that's high in carbon is going to basically just look brown, right? And that's going to allow it to persist on the soil surface throughout the crop cycle, so that we're not going to have the weed pressure. Now, what we oftentimes look for in our organic tilled systems is that we are looking for actually a low C to N ratio. So things that are like legumes that are a lot greener and that can decompose a lot more quickly, because that allows for that nutrient release as those crops break down via microbial kind of pathways and then make it available for the plant. So we have this real issue with how do we balance creating a cover crop that's brown enough that will last long enough with a cover crop that is going to produce enough fertility for us. So it's this, again, this kind of asynchrony and termination for cover crop mixes, right? If you have two different types of cover crops that you're planting together, say a rye and a vetch, those are going to terminate at very different times and create this issue around this trade-off between weed management and nutrient cycling. So when you look at how have some of these systems performed, and right now I'm actually really focused just again on organic commodity crops, so corn, soy, wheat. What you find is that most of the successful systems, yields are still falling about 24% behind the tilled versions, although given the reduced costs of production, that can make them competitive in a profitability sense. And this is actually true of conventional systems as well, that a lot of the reason that, you know, the conventional no-till growers that are successful are able to decrease their input costs and their expenses, their yields will decrease a little bit, but their profits, they'll actually come out better because of their profit. Most of the success of these systems has really been in soybeans. Soybeans are a legume, and as a class of plant, they are able to actually fix their own nitrogen or capture their own nitrogen from the air. Again, our atmosphere is mostly nitrogen. Soybeans are able to capture some of that nitrogen because of the specifics of the plant. And so most of the success in organic no-till has been in those soy systems. When you look at corn, corn has really not met economic viability thresholds because of, one is the shorter season cultivars that no-till organic growers are required to use, because again, they have to wait longer for that cover crop to get to its biological maturity to terminate for weed suppression, and just a lack of nutrient availability. And when you look at some of the wheat systems, we see declines of somewhat of like 50 to 75%. So it's getting a little bit depressing, right? So now, right, we've taken care of pesticides with the USDA organic no-till systems, but we've kind of created a bunch of other issues that we need to solve around cover crop management, nutrient management, and some of these agronomic basics, which are just like, how do you get the plant in the ground? How do you get the nutrient to the plant? How do you take care of the weeds that we didn't have before? So I'll move quickly to a little bit of the review of organic no-till vegetables. And here the literature really shows that, early on in organic no-till research, it was really characterized by early failures and a lot of inconsistency. So these are yield declines for tomatoes, zucchinis, and bell pepper year 1 and year 2. And what you see is, right, this real variability between years. But you also see this massive crop failure, right? Like 89% yield decreases, 92% yield decreases. And of the kind of 67 papers that are currently out there around organic no-till vegetables, over 80% of them were just published in the last 10 years. And really only one was published in California. That was one of the early ones on tomatoes. And so, this is quite, again, I just want to emphasize, I think there's a lot of thought in, when we talk about no-till, and folks that are really maybe call themselves foodies or interested, they imagine that, right, we can just do organic no-till vegetables, when really I think a lot of the academic literature is really, we're just getting going. And I want to highlight that, because this is so kind of new and unique, and I will call out, we have a special guest in the audience that supported this, some of this research, but, it takes people, the only reason that this research happened, given its kind of niche its niche area is because we had somebody kind of privately that was able to really see the value of this when it's not quite mainstream enough right now, I think, to really command significant interest from the USDA. As we continue to look at kind of what happened in the kind of the more recent organic no-till research on vegetables, again, mostly out of California, mostly in the Midwest, the Mid-Atlantic, and in the Northeast, we see just, again, these real amazing yield reductions of 97 to 80%, limited data, and really a couple of instances of success, which, specifically around kind of brassicas and solanums. So brassicas are your kind of broccolis, solanums are your tomatoes. So, when we look about what are the takeaways in terms of what the landscape is right now, again, catastrophic losses. So a real need for basic agronomic experimentation around these systems are just so immature in terms of how we understand how they function. And that, there's this potential that tomatoes and broccoli both have really extensive root systems. Again, not quite as robust as corn, but somewhat similar. Again, getting down to that 2 and 3 foot level. And that their ability to scavenge nutrients may be why they're so successful in these early organic no-till trials. Some issue about paired plasticulture, which I don't need to get into right now. But also, a couple of sporadic instances in the literature where really high levels of fertility applications sometimes resulted in yield equivalency. And, I kind of couch this in the academic sense to say, the fact that one person got this to happen in one trial in 1 year is not enough for us to base a whole, system off of it, but it is something to pay attention to as an area of study. So again, applying 3 times as much organic fertility as you would normally do in a tilled system, with this idea, again, that when we don't till the soil, which has the effect of both increasing the temperature and increasing the amount of oxygen in the soil, both of which spur that microbial process, we might need to apply significantly higher amounts of fertility in a no-till system to get the crop to perform. And then as we focus really specifically on the California context, and again, one reason why I was particularly interested in this research is that, we produce the majority of organic specialty crops for the nation, and specialty crops is really defined as like fresh fruits and vegetables. So these are the nutrient dense crops that we rely on, that most of the nation relies on. So when you look across a lot of the organic vegetables that are produced for the country, well over 90% are produced right in California, especially on the coast of California. California is also, again, highly drought susceptible. So there's these issues of kind of water. So when we look at California, this is, the percent of no-till acres, this was in 2017, California ranks well at the bottom of that ranking, 49th in the country. And really the idea here is that, again, back to that previous slide, these systems that operate in California are so vastly different than where no-till has been successful in the Midwest and the Northeast, where they have rainfall during the summer, where the crops that they grow are so different. And this idea that really in California, our crops are so high value and we do so much turnover that the systems are just, again, so radically different. So again, when we look back at, all of the list of issues, right, which there are a lot, one other issue we've added is also kind of, water in terms of how do we address this? So I'll pivot now. So that's kind of a little bit of the lay of the landscape. And I'll pivot now to a little bit about the trial itself. So, just a couple pictures. So this was, the way that we ran this trial is that we planted a white mustard cover crop. We then did different treatments. So we had a no-till treatment, a shallow till treatment that tilled to about 5 to 6 inches, and then our full tillage treatment that even while full tillage down to 12 inches, I would still characterize as very kind of responsible tillage within kind of an organic system. We then planted lettuce across those 3 different treatments. We had those treatments replicated 4 times. after the lettuce, we went into a a buckwheat summer cover crop, and then planted broccoli after that. So 2 crops in a year with 2 different cover crops, and we did that for 3 years. And so this is, again, the trial layout. So a replicated block design. So I'll go through a little bit of some of the findings, some of what our challenges were, and I'll move through this a little bit quickly, just so that we make sure we have time for questions and answers. But one was really just about the agronomic basics of these systems, right? This idea that so much of the literature that we looked at, the crop systems just failed, and we didn't know if it was challenges with how things were planted, how the watering was done. And so, some of the challenge of this trial was actually just I had to actually fabricate a lot of my own tools that would adapt our organic no-till or organic till equipment that's specific to California specialty crops, and adapt it with parts from the Midwest. And this was a real challenge because none of the equipment suppliers in the West really knew what to do with no-till systems, because nobody really does no-till in California. The folks in the Midwest had no idea what our specialty crop systems looked like. So there was a lot of, again, kind of custom fabrication, me relying on mentors and doing some custom kind of welding and machine work to get these things to work. And there was a lot of trial and error in terms of figuring out how do we actually get these plants in the ground. So you can see on the left was, our first year when we tried planting lettuce and the soil was too wet. Then we let it dry down a little bit and planted, and it was a little bit too dry. And then we finally figured out what that no-till planter looked like when the moisture was just right. So again, quite a big learning curve in terms of the agronomic basics. When we look at some of the results of the trial, a lot of what we saw in our trial really mirrored what, again, some of the experiences of some of these other systems. So we saw really significant yield declines. So FT is full till, ST is shallow till, NT is no-till. So again, really significant yield declines, both in our lettuce as well as our broccoli. We did feel like some of our broccoli yields were increasing over time in the no-till system. So it may be that, again, the system was too kind of young and underdeveloped, but again, yeah, really similar issues. When we actually looked at kind of the nitrogen mineralization, interestingly, we saw in some instances, that there was less kind of available nitrogen. So these are tests that we took on a monthly basis to see how much this inorganic N is basically like plant available nitrogen. And while in some instances we saw less nitrogen in the no-till systems, it wasn't consistent across the board. And so it didn't, we were a little bit perplexed in terms of why we were seeing these yield declines, even though there seemed to be at times really, abundant nitrogen. Water became a really big issue. We weren't really aware of this early on, but after the first year, we really saw something happening. And these charts are a little bit hard to read. Basically, the drier it is, the line is going to be lower on the graph, and these are separated by 15 centimeters, 30 and 45 centimeters. So we measured at 3 different depths. And we see that generally at 45 centimeters, the soil moisture holds the same across the treatments. We see some inconsistency at 30 centimeters, but it's really pronounced at the 15 centimeter level. So again, about that 6-inch level, where we just saw our no-till plots really drying down so much faster than our tilled plots. And this was really a function of the design of our system was such that we created a cover crop that we could terminate really early, so we could get 2 crops in the ground, but that wouldn't last for that long, so that we wouldn't have some of our plant back issues with residue. And because we didn't have that soil cover, we saw, again, the significant moisture loss that oftentimes when you have that mulch on the surface, you can see some moisture retention in other no-till systems. And this is what the crops look like. So, again, at 31 days, about 10 to 12 days before harvest, again, no-till, shallow till, and full till from left to right. Again, we saw, while the plants looked quite healthy, they were really just quite significantly smaller. We saw this across our buckwheat cover crops as well. And then when we actually looked at one thing that we wanted to look at was survival. Because it's something that I didn't see it anywhere in the literature, but had really been anecdotally passed down was that, there's some serious issues around gopher pressure in no-till systems. And the fact that when we're not tilling and disrupting their burrows, they're actually able to come back and take plants a lot more easily and a lot more quickly. And while we didn't see any kind of statistically significant differences across all our different plots, we did see some trends that I imagine if we had continued this research for another year or two, we probably would have seen some significant differences in terms of kind of gopher take of some of these crops. Again, soil temperature, we saw not very many differences in broccoli because of the size of the leaves and the canopy coverage that happens because of that. But I think in the lettuce, we saw the no-till actually operate at higher temperatures, which again is really counter to some of the other research, but I think really related to our lack of soil cover. So when we look at all of these kind of issues that come up in this no-till system, I think what we really see in a system that, again, we designed a system that tried to address some of the issues of kind of cover crop asynchrony and nutrient asynchrony by taking some of the cover crops out that are typically used and having less of a residue, so almost a no residue no-till system. What we really saw was a system that was kind of totally out of balance. What we saw is that, the interplay of all of these different pieces and challenges really needs to be looked at, I think, from a different perspective. So I'm going to go kind of quickly through some additional slides just to say that, our work was really paired with a number of large growers. These are folks that I like to say have been farming since before I was born, really established organic growers that were really working on reduced tillage in California on specialty crops. Their size ranged from 70 acres to over 1,700 acres, a range of over 50 crops grown. So a huge diversity, and again, really, really well qualified growers. I think what they really looked at in terms of, their experience was no-till was very similar, where a lot of the yields that they saw were kind of incredibly depressed relative to any of the full till treatments that they engaged in. So this was kind of a small trial that they did. I'm going to go ahead and skip this slide, but just talk a little bit about, while I think, so to paint the picture and kind of bring it to a conclusion, of course, talk about future research directions. The issues that we ran into, while incredibly challenging, I think also really spoke to some of what I think were really important lessons to learn and really important lessons, I think, for the broader conversation. Again, knowing that no research on this had really been done or published in California. And I think just, again, the potential of these systems to really operate and sequester carbon. So when I think about, how would we kind of design some of this future research moving forward, I still feel like there's a significant amount of work to do on some of the basic agronomic challenges around planting, seeding, high residue cultivation for weed management in organic systems, kind of fertility application and selection. And I really focus here, again, this comes back to, my work is really in the environmental studies department, and it's a really interdisciplinary major where we both focus on, while the agronomics of it can be kind of more kind of biophysical or natural sciences focused, we really also try to focus on, make sure we're incorporating a social science perspective as well. And, one of the takeaways from this is that, there's different ways that some of this research and knowledge is performed and passed down when you think about agricultural systems. And so a real highlighting of, this basic agronomic research in terms of how these systems function should be really done in an action knowledge approach, with this idea of kind of grower knowledge and intuition, less of a focus on kind of replicated trials, but really kind of throwing the kitchen sink at these challenges, adapting trials midway through, not necessarily running them for multiple years, but really trying to address some of these issues about planting when it's too wet, when it's too dry, how do cover crops terminate, things like that. And in particular, this second area is really the suitability of kind of cover crops and specific cash crop combinations. And so this is just this idea of, we tried something that folks generally thought was like a great idea, right? When we started this research, where we said, look, there's all these issues with growing a cover crop and terminating it at the right time and having it grow back. What if we grow a cover crop that we can terminate really easily, and that we can terminate really early so we can get enough crops in, but doesn't have soil cover? And folks said, yeah, let's give that a try. We really, I think, put the nail in the coffin of like that approach doesn't work in terms of how it, again, puts that no-till system really out of balance. And so you're really looking at suitability of different cover crops, and the combination of those cover crops with specific cash crops, I think is an area that we can really, again, look at these combinations. And again, I think this kind of hybrid approach of both kind of action-oriented, what do we see, what's our intuition say, but also this kind of epistemic knowledge approach, which is really looking at, some of the things that we can't really see in terms of kind of nutrient availability, and C to N ratios and cover crops, and really using the science, a kind of a more, academic and scientific approach to really understand those issues. And then the long term is just, and the last one is looking at these maybe potentially long-term studies that assess the potential of organic no-till systems on the kind of soil physical and chemical properties, really specifically around this issue of soil organic carbon sequestration. And again, I think I want to just bring it back to this idea of this quest for the holy grail, and knowing that, again, all of our indications in terms of the change in our understanding of kind of this dynamic equilibrium model of soil organic matter accumulation, as well as the success of organic systems and actually moving this soil organic, the carbon sequestration, across the soil profile and really at depth. I think we really need to take that into account, and see what we can do within kind of some longer term studies to enhance kind of some of what we've seen happen in small areas. So, really focusing on this might be something where we develop systems that aren't actually, don't involve cash crops, but we're not so focused on some of these agronomic challenges, but we really design a system where we're doing a lot of the no-till practices, we're adding organic amendments, we're laying down cover crop when it's biologically ready, and we see what happens to the soil in those instances. And again, this is where I like to say this is the perfect rationale for a research station at a university, because these long-term studies are not things that growers are going to do and commit to for many years. And indeed, many of the growers that are out, that have their businesses that have been running for decades, many of them are moving away from kind of no-till and reduced tillage work because it's just too challenging within the current economic constraints that they have to work within. And so I still think that there's a role for us as a university and a research station to do some of this long-term work to try to assess some of these things really that we're not able to see with our eyes, that really require some higher level analysis to continue to point towards what's possible. And I think that, that's a little bit where I'll end on this kind of where I think, why I think despite all of the challenges that we had, why this research is so exciting to me. I'm drawn back to something that one of these growers said to me at one point, kind of early on in the process, of like this work that we're all trying to work on to take tillage out of organic agriculture. It's really a paradigm shift. And she was really equating it to what it was like in the late 60s when they were trying to get chemicals out of agriculture. And that took decades of time and practice and work to really convince folks that organic agriculture was a viable production system. And I think that in many ways, we're right at the beginning of that research right now. And I think that it's really important for us to stay committed to it because of, I think, the challenge that we have in front of us and the potential that we see. So, thank you for that. That's kind of some of the research. Maybe I'll do just a quick couple slides on the Center for Agroecology, and this will be less than 5 minutes. I'll go through this really quickly, but my role now, so I just finished my PhD this past spring, but this past year, I've also been the director of the Center for Agroecology, again, been on staff for 10 years. And for folks like yourselves that, graduated from UC Santa Cruz, maybe you knew that we had a farm, right? The farm's been around since the late 60s, but maybe you didn't. And I think what I just want to share is what an exciting time it is right now for the farm and for the campus and for kind of the work on sustainable ag and food systems right now. So again, we do research, like I showed, we do a lot of education with our undergraduates now increasingly, and our new agroecology major. And we also do a lot of extension work or community work. So this is work with beginning farmers, really working on changing our food system. So one thing we've really been focusing on for the last couple of years is just a couple of areas, increased access, community engagement, and institutional change. So increased access is really thinking about, the center and the farm as a resource, making sure that we are making that accessible to the broadest range of students, and really crafting our programming in an intentional way to do that. And this is not just because diversity is kind of the word of the moment, but this is really because when we think about how much change is needed in the food system, we really need people that are going to be creative, that have lived experience, understanding the challenges of the food system, to step into roles of leadership, understand the issues at play, and really be able to make change and be at the table. So what I always like to say is that, drones are a really big thing in ag tech right now, and people are thinking about how to use them. And what I always say is that, the experience of giving somebody a drone that has no experience in ag and asking them what they're going to do with it and how they're going to use it, they're going to think about that very differently than somebody that's grown up, either with a farming background or with parents that worked in a field, about how they would think about using a drone in a system. And so again, some of what we do is really focus on hands-on experiential education, making sure that engagement is really meaningful for students, i.e. that it touches their community and impacts that they can kind of see themselves, and making sure that we're wrapping around the support for these students so that it's not just access to the farm via unpaid internship, but that we have kind of paid positions. So, I'll highlight a couple of things, at the farm, in the fall, we served over 300 course enrolled students just in that quarter, with about 30 or 40 students at the center each and every day. We have increased our programming to actually include a coffee shop and be engaged in the basic needs work of the campus. So we have a coffee shop that uses produce grown on site by students, supporting 8,000 visits or almost 250 free meals each day. So students just come to the cafe and get free food. And in fiscal year 24, we're going to employ over 50 students, starting at $17 an hour. And it's about $500,000 in student salaries that we'll pay out for fiscal year 24. And that is all money that we've been able to fundraise for in this last year. And I'm really excited about that. On the community engagement piece, we recently have a designation as an ag experiment station, which I can get into at another time. But, this is really, we are kind of being brought into the fold of some of the more standard kind of ag research opportunities. As organic has really been recognized as a viable system, we're really being brought into the fold, hopefully with some significant funding that will come at both the federal level and at the state level. And then when we think about kind of some of these levers of institutional change, our work with basic needs, where, again, we've shifted our production from growing food to sell through a CSA to now over half of our produce is just given to free to our students that are food insecure on campus. That has come with $1.25 million in state funding on a 3-year cycle for center programs, as well as we recently were part of a $35 million 5-year grant, regional business food centers. It's really looking at how do we improve market access for small and mid-sized growers. And we were recently awarded a USDA Next Gen grant. So that's $10 million over 5 years. For us and partners, it's really looking at how do we train these next generation of ag leaders and learners, really specifically focusing on underrepresented students and ag career pathways. So I'll leave it at that. I'll skip through some of this other stuff and just, we can go to questions.
Well, thank you very much, Darryl. This is Mike Reapy, your other volunteer organizer. Thanks for the intro, David. I want to thank you again, Darryl, for the amazing talk. I don't know if people remember our very first Slugs and Steins talk, because called Professor in a Pint back then, was from the farm. So we have come full circle, and I can't believe it's taken us this long to come back to the farm. So thanks for being here. We have some amazing questions rolling in. I'll give everybody a minute. Now's your chance to type your questions in the Q&A box, and please look at the questions that are already there. If you upvote them, David and I it'll give us some help on which questions to ask first. I'm actually going to start with my own question, though. I'll take a prerogative here. For those of us like myself who plant the occasional tomato or jalapeno pepper or maybe newly legal hemp plants right in our backyard, is there anything that home gardeners can take away from from this high intensity professional organic farming research?
Yeah, I mean, I think in some ways, the thing that we come up against a lot, and a lot of the ag extension agents that I talked to today, they're like, we need a video to combat all of the YouTube information that's out there that's telling people to not till their soil. Because what happens, especially with home gardeners, is that they see these people on YouTube saying like, no-till is amazing. You just put it in the ground, don't disturb the soil. It's all, the most healthy. Is that you do need to develop this soil before you can actually turn it into a no-till system. And a lot of times, in folks' backyards, the soil has been really heavily compacted. So I think if anything, I would just say like, what you can learn is that, follow some of the standard gardening practices first. You can move towards a no-till system, but do it after you've really developed your soil in some way. And for me, that means a lot of kind of amendments, right? So what that means is when we think about healthy soils and some of that high-end research, we're really talking about organic amendments. So what does that mean? It means manure, it means compost, it means any organic fertility that you buy at the store. That's all going to be good for the soil. The second is that, when we talk about microbial processes being the baseline of kind of soil health, we talk about always having things growing in the soil for as long as you can. Because what we know from the research now is that plants, when they grow and photosynthesize, that process is basically taking CO2, right? Taking it into the leaves, taking sunlight and creating sugars, which are a lot of carbon. What we know now is that they take over 50% of that carbon, pump it out of their roots to actually feed the microbes in the soil. So as much as you can have plants living in the ground, you're going to improve your soil. So that means that if you're going to plant the jalapeno plant, think about a cover crop for the winter. If you're like, oh, I don't want to plant it this year, do a summer cover crop if you can afford the water. But those are the things that I could say. Living organic amendments.
Thank you.
Thank you. Beth asks, how much does tilling contribute to poor air quality in California Central Valley? And so the question is, how much has no-till been evangelized there, and what has been the reception?
Yeah, so huge impacts. So tillage has huge impacts on air quality, especially the way that the conventional management of tillage, you're looking at on average like 13 to 15 passes to do bed prep. So that's different passes of the tractor with different implements. And the way that we oftentimes think about it, or the way that we describe it from kind of an organic perspective, is that some of these conventional systems, they're really looking at the soil as a medium for growth rather than the soil as an ecological system that you need to nourish, right? And so when you think about it as a medium for growth, you have a different approach to it where you're going to move that soil, till it, and pulverize it to a dust, because when it's in that dusty form, it's so much easier to move around, to shape the way you want it, to manage your weeds. But what that means is when the dust kicks up, you have this pulverized dust that gets into the air and can really get into people's lungs. And yeah, there's huge health impacts associated with it. So that said, one of the researchers that we participated with that helped to run this trial, he's been pushing no-till both conventionally and organic for decades in the Valley. And it really still has these really low adoption rates because the economics of it just have not worked out. And again, I think this really speaks to how do we incentivize growers? And we've really kind of externalized these human health costs onto the communities in which agriculture operates. And so they take on the costs of that rather than having some other kind of mechanism to control for that. But, you know, I think we're getting there, but I'd say, you know, generally it's been fairly poorly received.
So Katie is asking you to right turn into politics here. What are you hoping to see in the new farm bill?
Oh gosh, that's a really tricky question. Paul, you know, I think Mark Lipson's on the call here. He's our kind of resident center policy wonk. So I would kick it to him if he could, but since he can't chime in, you know, the biggest thing for us, if folks are interested in policy, I would point you to the Organic Farming Research Foundation. It's a local nonprofit in Santa Cruz, but really has national reach in terms of its policy work. They're doing really good work. And I think the biggest thing for us is really supporting organic research. You know, there is such a mismatch between the amount of organic production that we have, the growth of organic acreage, and how much research money is allocated towards organic. It is not even a drop in the bucket of the farm bill. And we have to fight so hard to get it increased. I think we're at $50 million annually. And that, I mean, the farm bill is billions of dollars, right? And so all of us organic researchers and folks that are really trying to move this work forward, we're all competing for this really small pot of funds that comes out of the USDA. So I'd love to see organic research increased. Yeah, and I guess what I'll say is that, you know, I'm very sensitive to, the conversation around regenerative ag. There's a lot of kind of interest in it and hype around it right now. And what I want to make sure that folks really see is that they see organic as regenerative, right? Organic is really a tried and true production practice that has a lot of the soil health benefits and increases in soil carbon, right? Relative to conventional systems. We've seen this. But I think there's a little bit, we're feeling like the regenerative kind of conversation is in some ways hijacking what is kind of the organic systems and the potential of organic. So that's a much deeper conversation that I would love to have with anybody. But yeah, I'll leave it at that for now.
I think that's a great start. Thanks.
I might not let it rest with that. I'd like to slide in my own question. So apart from government collaboration, it sounds like the USDA is not currently a big partner for high-risk ventures. So what I'm wondering, if you move outside the government sector, which organizations are movers or risk takers in this realm? There's a lot of trial and error that has to happen, it sounds like, a lot of innovation, a lot of venture style funding. So this sounds like a Silicon Valley endeavor in some respects. Who out there do you have hope for in terms of supporting this kind of thing currently?
Well, again, I'll just reference, you know, for us, it was actually private philanthropy that had the vision to make this patient investment in this agricultural research that actually has can have a long turnaround time. When I talk to beginning farmers in my I have a so you want to start a farm class, right? And what I show them is kind of the learning curve for farming, and the idea that if I've been farming for 15 years, that means I've only planted potatoes 15 times, right? Compare that with the way that AI is running iterations of millions of times in a day, right? These are very different systems and times that you have to operate. So I actually think that this is really not a Silicon Valley issue. They're much more focused on, I think, quick fixes and ag tech. And how to do that. But what I think, I think we need to make, more of these kind of patient investments in understanding how these systems perform over time. And in some ways, I think, acknowledging some of the research that I think is being done, and some of the systems that we have in place. So, I would love to see what we could do from an organic perspective and a sustainable perspective with the budget, not to throw anybody down in the UC system, but with the resources that UC Davis has in their ag department, right? I mean, it's just night and day. So, so I think it's going to take folks that really believe in what we're doing and see the value in it. And luckily we have a number of people that are, I think, yeah, really see that value. And I think increasingly more and more folks understand that.
Okay. We're getting several questions from Wendy. Thanks, Wendy. I'm going to sort of combine two of them because they look similar. She seems interested in like exactly how you do cover crop management and tilling, right? Why is the roller crimper better than mowing? And B, is spading a cover crop considered limited till?
Well, I'm wondering if this is Wendy or if this is Tim. On Wendy's account. If it's Tim, I've admired your work for a long time. So let's connect after. But yeah, for these technical questions, crimping is much better than mowing, because in mowing, when we shred up that cover crop into smaller bits, we see faster decomposition. So we don't actually see the weed suppression that we want. Kill rates can be similar based on the biological stage of the crop. But again, when we're looking at actually putting that mulch in place and having it stick around for a long time, we see, I think, tend to see better results with the roller crimper. There was a number of, I don't think I showed it, but folks have been playing around with these smaller mowers that actually are mounted on a toolbar so you can mow around the crop line for cover crop regrowth. But it just hasn't really taken off. And then what was that? The second, spading. Is spading considered minimum till? I mean, I consider it responsible till. I wouldn't consider it minimum till. But again, when you think about the number of passes that we're using, where we do a single pass with a spader versus the number of passes with a disc, I do think we're doing probably less disturbance overall than some of these heavy disc and chiseling systems. But, so much of that I think is really dependent on operator skill and timing around moisture, which again, you would know. So I think, I've operated systems again that are low budget, that only have, chisels and a disc. And I think that you can actually manage your soil quite well with those systems, similar to a spader. But, maybe we could improve it better, quicker with the spader, but I'm not 100% clear on that.
I guess I thought Wendy meant like a shovel, but is a spader a particular attachment?
Yeah, that's insider lingo. So that's a tool that we use for tillage, and this was a tool that we used for our full tillage trial. If folks know about double digging, right, it's the idea of kind of using a garden spade where you just take a chunk of the soil out and then move soil just with a shovel. And they've created an implement that you put on the back of a tractor that basically does the work of like 6 shovels at once. And it's a really nice, it's a slow tool and expensive tool, but it's a really kind of great tool for what we consider kind of responsible soil management and soil tillage.
Wow, thanks.
Gabriel asks, with the potential increase of urban produced compost coming out of California SB 1383, what does that promise or have an application for organic no-till systems? Does it need tilling to incorporate this urban produced compost?
Yeah, that's a great question. And what I'll just maybe pin, we have new faculty coming on in environmental studies, a woman by the name of Hannah Waterhouse, and she did her work at UC Davis and then did a postdoc at UC Berkeley, and she's amazing. She's an agroecologist and is kind of coming in to replace Carol Shannon for those folks that knew her work since she retired this year. But she's doing, she does kind of watershed and nutrient cycling. And she is actually doing some work on looking at the different, when we think about that, all that compost that's going to get created, what we like to say is compost is not compost, right? If you create compost from yard waste, it's different than if you create compost from food scraps, and it's different than if you create compost from horse manure, right? All those different, we call feedstocks, or the inputs, those will create different qualities and attributes in the compost that's then going to impact how it performs agriculturally. So I think, so Hannah is actually doing work on looking at those different qualities and how that impacts how that compost functions, and specifically how it functions in terms of leaching. Because what we know in these organic systems is that you can apply a ton of compost, but if, say, the ratio is too high, if it's too high in nitrogen, and you see a really heavy rain event, you can actually see nitrogen leaching into the watershed from that compost that should be somewhat stable, but because of its composition, it can be a little different. So that's a long way of saying, I think it's going to be very interesting to see how all of that compost that gets created is applied across the landscape. I don't think, I'll move a little bit out of my niche of like organic no-till systems. Again, I think that the biggest promise is heavy applications of high CN ratio, so high carbon compost, which this landscape, again, yard trimmings and what we might get from the recent legislation, it may be in that category, may not, but high applications of that are done in a no-till system that allows those nutrients to cycle rather than to leach, right? And that gets back to that dynamic equilibrium process of soil organic matter creation and kind of maintenance. But I think there's been quite a bit of research on looking at how compost application on rangelands can actually sequester carbon as well, and in perennial systems, because those are already systems that don't have tillage. And we see pretty good results in terms of increases in soil carbon in those systems as well. So I think it's going to be a net benefit, but I do think we have to be careful in terms of making sure that we don't create a certain type of compost that actually is going to be given to certain systems that are actually going to increase nutrient leaching into our already impacted aquifers and watersheds, right? That's a serious issue in California already, mainly as a result of agriculture, right? And that's really well documented. So yeah, great. That's a super great question.
Yeah, thanks. I've always wondered where the stuff I leave out on the street goes. I have an interesting question from Todd. Todd is a mushroom fan. There are important antioxidants in mushrooms and other plants, and it enters the mushrooms and other plants from the microbes in the soil. I think Todd's even aware of some studies from Japan where longevity correlates to mushrooms. Tilling reduces the concentrations of this antioxidant. Is that another justification for no-till?
Yeah, and there's a lot of, it's a little bit, I don't think we quite know from, again, the kind of academic and research perspective in terms of how these systems have the potential to increase basically fungal prevalence in agricultural systems. There's a lot of talk right now about fungal to bacterial ratios, with the idea that in a no-till system, when you're not disrupting the hyphae or like the fungal roots, basically, that you can have better establishment of these communities and you actually see a higher prevalence of fungi than bacteria. And folks will say that's a good thing or that's a bad thing, but truth be told, at least in terms of how I understand it, which again, this is not my area of expertise, so I could be kind of stepping out leaning out over my skis here, but we are just beginning to understand the tools that allow us to analyze what those communities are. We don't really have an understanding of what the functions of all those communities are. So we do know that certain types of fungi are really super important for crop growth and crop health, the arbuscular mycorrhizal fungi, but we don't necessarily see the correlation in our no-till systems at this point. So, but I think I would guess that would be the case, but again, I don't think we have the backup on that right now. But yeah, I think that's a great point.
So Deborah has a question about the concept of permaculture and what the relationship is to no-till. Are they similar?
Yeah, permaculture, what's interesting is that, again, we are the Center for Agroecology. Previously, we were the Center for Agroecology and Sustainable Food Systems, right? So I think there's all this kind of terminology around this idea of how do we do agriculture in a more sustainable way. So there's so much interconnection, overlap between all of these ideas of sustainable agriculture, organic agriculture, regenerative agriculture, permaculture. So I think that, yeah, a lot of the principles and practices of permaculture would incorporate around no-till, this idea of thinking about systems and nutrient flows. That's all very much in the kind of permaculture space. But, you know, for us, I think we continue to try to think about, just how do we continue to, I think not just in some ways be dogmatic about one over the other, but really think about how do we, you know, especially as a university system, folks that are training students in this, you know, make sure that we point to all the different aspects of all these different things, so that people can really kind of pick and choose as they may need to and as the science changes.
Right. And again, thanks for your questions. We could use a few more upvotes to help us out here. We'll probably take questions for about 5 more minutes. So 2-3 more questions. Question from Sumi about nutrient intensive crops. Each crop should have different requirements. Do vegetables take more and make soil depleted in general? So.
Again, yeah, really crop specific, right? And a lot of this has to do, so what lettuce and spinach might use something like 80 to 120 pounds of nitrogen over its crop cycle on a per acre basis, whereas something like broccoli is going to use well up in the 280 to 350 pounds of nitrogen per acre. So really different based on vegetable crops, but, you know, generally I'd say, you know, corn and soy are also fairly heavy feeders in terms of their nitrogen requirements. Soy gets a little bit of a leg up because it can create its own nitrogen. But yeah, I think there's maybe, if I can answer your question a slightly different way, and this again gets to kind of a broader perspective, is that, you know, some of the problems that we're trying to solve are problems in some ways of our own creation, right? In that a lot of we know how to run a system, like a very balanced ecological agricultural system that's probably hand scale. If it's not hand scale, it involves a lot of diverse rotations that include fallowing ground, putting it into pasture, rotating with animals. But those systems are not economically viable right now based on how we construct land rents, how we think about food as a private good versus a public good, right? And so these are all issues that I think maybe get to this question of like, what are the crops that we can grow in a no-till system that are nutrient, right? Like we could create a no-till rotational system, but again, it would have to be outside of kind of our current economic paradigm that really dictates so much of what happens ecologically on the ground. So again, more to go in that direction if folks are interested, but I'll leave it there.
Mike, are you going to take Stuart's question?
Oh, why don't you go ahead? Yeah, sorry.
All right. So it's the battle between the cover crops and the target crops. For root space and sunlight, if the unwanted plants are allowed to continue to grow in the same space, this competition, is that in effect what reduces crop yields, or does it end up being better for no-till?
Yeah, it is about water, nutrients, light, all of it. You know, the cover crops basically become a weed. And especially if they have already had a number of months to grow and establish a root system, they're going to be much more effective at scavenging what nutrients are there compared to, you know, little seeds or seedlings or transplants that you put into the ground. So that is really what we're managing for. And yeah, needing to figure out that timing of, you know, when can that cover crop be brought to maturity so that we can, you know, kill it, but then be able to, be able to plant a crop that can kind of subsequently follow up from it. The other issue, you know, again, in organic systems, when we till in our cover crop, we are taking all of that plant material, all of that biomass, and really stimulating like a rapid flush of nutrient release from that decomposing material. And that is what many organic systems really rely on, is that, again, changing those environmental factors and really encouraging that that nutrient availability. So, you know, again, we have that added issue in organic systems where not only are these cover crops continuing to compete, but even if we do kill them, we're not seeing the similar rates of decomposition that we would normally see that support our crop growth.
Okay, I think we'll take one more question, and we'll make this quick, but I think this is a good way to finish out the talk. No-till seems better in the short term. What's the picture in the long term? Are all downsides of tilling should make a difference sometime? Or will the downsides make a difference sometime?
Well, I think maybe I don't totally understand the question, but I do think in the long, no-till feels like a much, in the long term is where you see the benefits. We're seeing challenges in terms of transitioning the organic systems right now. But I do think, like, I could imagine a very interesting trial where you take basically a mature conventional no-till system and transition it to an organic system, something that's, again, 20 or 30 years old, and really switch it to organic no-till, and do it in a way where you're really laying on those organic amendments and really supporting cover crop establishment. And I think it would be really interesting to see what happens. Because again, I think this is really a long-term issue.
Okay, thank you. I want to thank everybody in the audience. Thanks for your amazing questions. As always, we couldn't get to them all, but thanks for the audience for helping us with upvoting those things. And I'm sorry we didn't get to all your questions. Please, everybody, join me in applause. You can click the you can type some comments in the Q&A box if you like. Help me thank Executive Director Darryl Wong from the Center for Sustainable Agriculture. And also, please help Darryl advance the Center for Agroecology's work by making a contribution and become a member of the UCSC Farm and Garden. A link is dropping into your chat box right now with some more information about how you can join. They really do amazing work and all across the spectrum. Our thanks also to the staff of the Alumni Relations and Special Events offices who organized this webinar with us. Thank you, Shana, Diana, Paulina, and Kristen. Also, April, one of our co-organizers who could not join us tonight, but she's also a co-organizer of this series. So hi, April, if you're watching. Our next Slugs and Steins will be Monday evening, August 14th at 6:30 p.m. and it will feature historian Eric Porter. Professor Porter will discuss San Francisco International Airport, or SFO, as a site where history reveals important perspectives on a wide range of phenomena that have helped to make the Bay Area. SFO can provide a useful lens for examining some of the complex, interconnected forces that have influenced the development of its region over time. It's a talk not to miss. There are a few other summer events that we would like to bring your attention to. First, we'd like to highlight a new and exciting program called Return to the Redwoods. This is this year's iteration of Alumni Weekend, and this is happening August 18th through 20th. If you haven't already signed up, we should be getting a link in the dropped into the chat box right now. Mark your calendars for August 18 through 20. This event welcomes alumni, friends, and family back to UCSC for a weekend of celebration, exploration, and an opportunity to relive the beauty of our campus. Reserve your apartment or residence hall and join us in the Redwoods for a weekend of reminiscing and making new memories. I hear that the dorms are filling up, so reserve your spot today. Another good reason to come to campus is on Tuesday, August 22nd, to join UC Master Gardener and Garden Company Advisor Loretta Heath to learn about how to grow avocados in our Monterey Bay area. Also, you can see Darryl Wong again in person at the Hay Barn on September 6th from 5 to 7 p.m., where he will again discuss the results of his PhD thesis on no-till farming practices on the Central Coast, and you can ask him your questions in person. For a full list of upcoming events at the farm, check out Agroecology events webpage. The link is dropping into the chat box right now. And for a complete list of events across campus, you can always visit events.ucsc.edu to see the full calendar. On behalf of the UC Santa Cruz Alumni Association, thank you for joining us tonight, and please come back on August 14th at 6:30 p.m. for our next virtual event. Good night, everybody.